How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a D10 ripper lift cylinder that's come in for repair. On a dozer, especially the bigger machines, they do have two ripper lift cylinders, one on each side, which lifts and lowers the ripper frame while the machine is in operation. They also have tilt cylinders on top of them to tilt the pitch of the rippers depending what ground they're working in. These are a very, very common component to get damaged or completely destroyed. Thankfully, someone was kind enough to point out the issue with this because I would not have seen it. It's come in because it has torn the eye completely out of the end of the cylinder barrel. One of the main reasons why these fail is the grease port that was put in from the OEM. It is pretty much a dotted line to where it is going to fail. So another reason these can actually fail is there is a lack of maintenance. These do a lot of movement while they are in operation. If these aren't greased of a morning or an afternoon, start or finish of a shift, they tend to dry out, and sooner or later the bush and the pins start to wear each other out. When they start to wear out, there starts to become movement between the two, and then finally they start to hammer each other, and the result is cracks in the eye. Judging by the look of the way this has failed, the grease port has caused the crack, and it has been cracked there for a very long period of time because the other side, it has got the cleanest surface, so it was the last thing to break. It was working for a period of time, not sure how long, with the crack through the grease port. Finally, it stretches the eye out and elongates the hole. After it does that, it finally breaks the eye completely off the cylinder barrel. However, that is not the only problem. So when the customer disassembled this cylinder, it was sitting upright on their ram bench. They didn't bother to turn it over and have a look underneath, and they would have found multiple cracks forming in the base of the cylinder barrel. If the eye didn't break and this had kept working, sooner or later it would have pulled the complete eye out of the base of the barrel. So I wasn't notified about these cracks, and the customer didn't know about them either. I didn't plan to have to try and repair the whole bottom end of this barrel. So what we need to do is set it up in the saw, we'll cut the old eye off, and we will grind those cracks out to see how far they go. And if they go too far, it's pretty much a write-off. Righto, so I've gone and cut the bulk of the material off around where those cracked areas are. I did grind one of them out. I didn't find the bottom of the crack. So what I'm going to do now, rather than remove excess amounts of material with a grinder, I'm going to grab the die grinder and I'm just going to try and find the base of the cracks to see whether this is at all salvageable. If the cracks go all the way through into the barrel, it's not really worthwhile trying to repair that because it's pretty much guaranteed to fail. When we do run into situations like that, we do have a second option, and the second option is we completely replace the barrel end. We do keep one of those in stock. We get them pre-machined from another company, but that is a massive expense because they do start out as a really big piece of solid material. So we're just going to see if we can find the base of these cracks. Yeah, got it. I got another one again. That one. So I was able to chase out all of those cracks. The good news is they didn't go all the way through the barrel. If there was any chance they were going through the barrel, there would have been oil and smoke coming back through the cracks as I was grinding it out. We didn't see any of that. I have checked the inside, the cracks didn't make it through. So we are ready to continue the repair on the ripper barrel. The next thing I need to do, I need to weld up what I've ground out. And I'm not going to use a MIG welder for that, I am going to use a stick welder. The material I'm going to put back in there, they're called an Ostark 77, that is the WIA equivalent of a 7018, and the reason I'm going to use that is when I was working in the field, they were the only rods we would use when we would repair such jobs like this. I know MIG-wise have come a long way in the last 10 or so years, but I'm just going to stick with what I know works. Right, so that repair went really well. I am very confident that there will be no further cracks in that. So while I'm waiting for that to cool down, I'm going to take the eye over to the lathe and start machining. The material we're going to use to replace the eye, it is a flame cut blank of 100mm high tensile plate. We keep these in stock because these are a very high turnover component. The shape and the thickness of the eyes throughout the Dozer series do vary and change. So the eye we have here, that will suit a D8 and a D9, and the eye beside it is for our D10 and D11s. I need to get this eye cleaned up, just give it a quick grind, and then we'll take it over and set it up in the lathe. So the first thing I'm going to do, I'm going to face it just to clean up the surface. I'm then going to rough bore the ID to within 1mm of its finished size. The welding process will pull the eye out around, so I don't want to machine it to its finished size because it will end up being oval. Once the welding process is complete, we'll put it in the milling machine and we'll finish bore the ID to the size required. The reason I don't do all the boring on the milling machine, because this is a high tensile plate and it is flame cut, that flame cut edge is very hard. If I was to attempt to do that on the milling machine, using the baby boring bars and the boring head, they run a TCMT insert which are quite small. It would just tear up inserts, where on the lathe I can put a big boring bar in there and I can chew that material out. This is far quicker and easier for me. Righto, so we've got that bored to within 1mm of our finished size. So now that that's done, we're going to take it over to the saw. Righto, so we got the eye prepped up now, we've cut the bevels on that. The barrel end has cooled down enough now that we can quickly grind this and then do a dye penetrant test just to make sure there are no more cracks. So the dye penetrant test showed there are no cracks in our repair, so now we can get on to fitting the new eye. Righto guys, so it was a bit of fiddling around to get this set up, but we've done enough of these in the past that we know the combination of the V-blocks on a standard barrel with the multiple blocks underneath the eye holds the eye up to the right height to get it back on the center line of the barrel. Right, so we've got the eye tacked on, we've got our support plates tacked on, which will also be used as runoff plates. The first thing I'm going to do a couple of passes on each side just to lock that eye in position so it doesn't want to move on me when I go to fully weld it. After I do that, I can then take it off the bench, put it down on the turning rollers, because it's just going to save me from manually flipping this on the bench. The welding wire we're going to be using will be Hobart XL525. And the gas we're going to be using will be Argo Shield Heavy, which is 80% argon, 20% CO2. The reason I'm going to be using MIG and not stick to weld the eye onto the barrel is because MIG is a lot faster. It's a little bit more controllable. That's the process that has never let me down before, so I'm not going to change today. Righto guys, so that's been cooling down for the past couple of hours. What I did after the welding process, I used a 9-inch grinder to remove the bulk of the material. Then I went in with a sanding pad to blend everything in really nicely. Really happy with how that turned out. So what we need to do now, we need to take it over the mill. I'm going to finish bore the eye to spec, and then I need to drill a hole for the grease port.
This is extra special.
Righto guys, so we've just taken our first cleanup cut. I have measured the bore. The bore size we are shooting for is 4 inches, which is 101.6. At the moment it is sitting at 101.49, so we have 0.11 to come out. So we divide that by 2, and that's how far we advance the dial on the boring head. So we shot pretty close there. Usually I don't try and get that close, but we've still got material to remove, so we're still in good shape. Righto, so we are about to drill the grease hole for the grease port. We are not going to put it back in the standard location because that becomes a dotted line for a crack to occur. What we are going to do is move the grease hole toward the barrel, get it away from this really thin area, put it through a more substantial area of the eye, and that helps eliminate any cracks forming in the future. Goes. Righto guys, so the job is now complete. Everything went really well considering we weren't expecting the cracks in the barrel end. This is about a day's work for us to do, so it's very economical to do a repair like this. If the customer was to go and try and replace the barrel, he could be looking in the vicinity of $6,000 to $10,000 depending on if it's available and whether you're buying genuine, aftermarket or a second-hand part. So the customer's going to be really happy with the repair. Job's done. We're going to get it back to our customer. Thanks for watching. Ready?
Sure.
Whoa. What we are going to move is... Fuck, I lost what you said.
Oh my god.
Fuck, how did you start that? Oh, wait, where are we going?
Because.
Oh, wait, what's the reason?
I don't know.
Right, so what we're going to do, we're going to make a new eye, and then we're going to... Fuck. We do a lot of fucking in here, apparently. Right, so on a D10 or a D9... Oh, fuck me. You may remember... Oh, there was... Oh, fuck me. Fuck me. English, dude. So what I'm going to do, I'm going to face the eye. I'm then going to rough bore it to within a mil of its finished... Oh, fuck, I didn't say ID. Right, so what I'm going to do, I'm going to face the eye.
Oh my god, let's do it sentence by sentence.
Right, so the first thing I'm going to do, I'm going to face it, and then I'm going to rough bore it. Oh, fuck. Right, so what I'm going to do, I'm going to face the eye off. Fuck, hang on. It's not funny. Ready?
Yep.
Are you sure?
Yes. Are you ready?
I'm not ready ever. So I'm going to bore it to within a mil of its finished size. Fuck off, train.
Oh my god.
I was smashing that. Fuck off, train. That looks like shit. Oh, shit.
What, is that right where it needs to be? 87.4.
Yeah, 874.
Wow. That's a fluke and a half.
Hell yeah. Got it strapped down, we're going to get it back to our customer. Thanks for watching. I forgot that bit.
Ah! Get it.